Welcome, I'm Eric Ostini, Product Manager for AgieCharmilles. Been with the company for 20 years. I'm currently Product Manager for the EDM and milling products, and I'm here to introduce you to the AgieCharmilles AC Form 20 machine with the new HMI control. The machine is a die sinking EDM machine. It has a C-axis frame, so it's a short C-axis frame, allows for large work pieces to be added to the machine. It comes standard with a linear tool changer, 4-position typically. That is either System 3R or an Aroa system added to the machine. C-axis is also standard on the machine, allows you to hold up to 55-pound electrode and maneuver that with full power to the electrode during a spin or a indexing of that electrode, for example in a helical type fashion, burning down into the material. So the amperage on the machine is 80 amps, and that is again whether it's stationary on the C-axis or in a helical move in the movement of the machine itself. The machine has a traveling table, so the X and Y is on the table itself. So we have the X moving in this direction, the Y moving in this direction, and then we have the Z head which comes down. The travel of the machine is X of 13.8 by 9.8 by 9.8 in Z. So lots of travel on the machine, lots of versatility in this small compact design of a machine. So as you can see here, the door frame here is just over 27 inches in door frame, but on the table we have a magnetic base, so it makes it very easy to set up a part on the machine. Just lay your part down on the magnet, lock it down, and then we're off to go on the new HMI for a setup. One of the key features about the Form 20 is the new AC Form HMI. Reason it's a key feature for us is that we've designed a interface for the die sinking line that is very similar to our wire EDM line. So the learning curve to go from wire EDM to die sinking or vice versa has been reduced because we use the same concept, the same layout. So on the first section you see here, which is the main page, we have 5 sections here, and 3 of them are small and 2 of them are big. And the reason for that is that the 2 big side is mainly where you're going to go to do things in the machine. So we have the preparation and the execution. And when I click preparation, it will ask me a very simple question right in the beginning. Do I want to start from an existing job, so basically a modal type job that I'm repeating over and over and over, or an empty job? And I'm going to say empty job in this case here, so we can start from scratch. All right, now that we're in the HMI, let me explain just a little bit about it. Up at the top we have what is called the mode buttons. This is an area where you can go from prep to execution, to files, to manual, to service. But right now we're in the preparation. It has a green bar and it has a green around it. And the reason for that is that it's similar to our older controls, but it also gives you a view from a distance of where you are on the mode from across the room. So on this side here is what we have as steps. And the way the HMI works is we work from step to step to step all the way to the bottom, and once we reach the bottom we are done with the program and ready to execute that job. Here we're introducing the Micron HSM 200 ULP. The U stands for full simultaneous 5-axis machining. As in this part right here, we're doing full simultaneous 5-axis machining of type of part for the automotive industry. Now the machine, the HSM 200, is basically designed for the medtech industry or the watch industry, or for general mechanics when they're doing some small detailed parts. The machine has a polymer base onto it. It's basically a polymer granite, so it's a very stable machine, and because it's a very short C-frame design, it adds to the ultra high accuracy of this type of machine. So when we get into micro machining and milling, or in the dental or medical industry where you need to do detailed work, this machine can do that type of work. So as you can see here with the travels of this machine, you have your Y in the lower head, you have your B and A in the lower head, and then you have your X and Z in the upper head. So you have a full simultaneous 5-axis machining of a part. Now the average size of a part for this type of machine would be 100 millimeters, so just under 4 inches in X, Y, and Z. So that's the typical size of a part that you could put on this size of a machine. But this uses a Heidenheim 530i control. The machine has a built-in wizard in it so that you can draw the part and then cut away on that part, and you can visually see it while you're cutting on it. So it has a nice wizard interface for doing that. Standard type of keyboard makes it easy for editing programs as well as inserting. So you have your insert buttons here for different types of corners when you're designing the part. And then as well you have here your positional type things, so going into manual mode for using the remote pendant or doing a tool change on the machine, tool definitions, that type of thing. So you can see it has a 30 position tool changer on it. Right now we have the probe in position number 1. That is its only position. It's used for the probe. The rest of them are tools that can use up to 50,000 RPMs. It doesn't necessarily mean the machine only runs at 50,000 RPM. Now the tool changer is a very fast tool changer. It's 4 seconds from to do a tool change on the machine. So your chip to chip is around 5 seconds, 4 to 5 seconds. So opening the door here, you can see now the inside of the machine. Now right now, during this part, we're using an oil mist on the part. So you can kind of see the chips sticking around the part itself, or down in the bottom there where we have a small drawer where the small chips then reside in, and a very easy drawer to clean out. Just pull it out through the front of the casting, and we can then clean out the chips and slide it back in. On the wire EDM side, our newest models are the Cut 100 series machines. We have right here the Cut 300 SP, and over on that side over there we have the Cut 200 MS, which I'll show you the differences in a minute. This has a swing open door. When the water tank is full, I can't open the door. Once the water goes above table 0, it prevents me from opening the door. On the Cut 300 SP machine, we have what is called a Quadrax design. What you're looking at here is the Quadrax design. The casting, which is the white area that you see down here, that's the polymer granite material. Here we have a bridge style design. So the Quadrax design has a bridge style where the X and Y hang off of the bridge underneath. And you can see the X glass scale right here. The UV axis is on top of the bridge, hanging up here, and you can see the glass scale of the U axis right here. The V and the Y, their glass scales are along the sides of the axis travel, and you see the Fanuc motor right here on the Y axis right now. So that's the Quadrax design with the glass scales, and then obviously the Z is up where the Z axis goes up and down in there. So because we have the Quadrax design with the glass scales, we have a full collision protection on all the axes, which is also at the full travel speed of the machine. So during a rapid move, if you crash into anything at 3 meters per minute, it won't affect the part, the machine, or even getting back to a wire alignment. Because of the Quadrax design, this machine can go to 30 degrees taper standard, but it can go to 45 degrees taper. And the key thing there is because of that Quadrax design, we can do that 45 degrees at the full travel of the machine. It comes with a polymer granite casting. So this is not sheet metal, this is the actual casting of the machine. It is a polymer granite material. It allows for 10 times better thermal stability, as well as 8 times better in vibration dampening, which allows for more accurate parts in the machine. So threading on the machine, the diameters of wires on the machine can go from 13 thou diameter all the way down to 3 thou diameter wire. And with the 13 diameter wire, we can hit those rapid industrial speeds of 37 square inches an hour. And auto threader can be threaded fully submerged. at 15 3/4 inches of threading. And I will thread the wire machine right now. And what you're going to see here is the water jet comes on. Here I'm going to cut the wire on the machine. First thing it's going to do is it's going to feed the wire a little bit. Then it's going to stretch the wire using heat inside the black tube above, and then cut it. And then the wire is then going to be ready to be threaded in the next operation of threading. So here I'm going to now thread the wire in the machine. So first thing that's going to happen is the wire is going to feed a little bit. Then the water jet's going to come on in the lower portion and feed the wire down into the lower head. And there's the wire threaded. So you can see we have a very fast threading system on the machine. We can cut the wire and thread the wire in under 20 seconds. Here I'm going to show you the Quadrex design by moving the U-axis out of the machine. There we're already past the 45-degree angle, and we can go even further because the travels of the UV is the same as the XY on the machine. So therefore the machine has no limitation to the taper it can do. The limitation really comes from the wire itself, that it has to do this bend and it can't do it. This machine can hold a workpiece of 3,300 pounds. Also the table is 56 Rockwell chrome hardened table, allowing for longevity in cutting parts on the machine. The glass scales on the machine in the XY and UV are all 50 nano glass scales on all axes. This allows for the machine to cut at speeds of 37 square inches an hour. And what I'm going to show you right here is a straight line cut into the side of a part. So I'm going to hit cycle start here, and wire is going to kick on, flushing is going to kick on, and what we're going to see here is the part being cut into the face. The Cut 300 SP has a 21.7 inches in X by 13.8 in Y by 15 3/4 in Z. Now what you see right here is full power right into the side of the part without any modifications to the generator setting. Just set up the job, tell it where you want to go, tell it what power you want to use, and let it go. So right now we're in the part itself, so I'm going to raise the Z head, come out of the part in the Y negative direction, and move in the X direction. Now the fast speed of this machine is 3 meters per minute, so that's the travel speed of the machine, and it's full crash protection on the machine. So if I would happen to hit anything with the lower head or the upper head, like for example this block or the tooling that's holding the part, it would then automatically stop due to the crash protection in the machine. On the HMI, on the Cut 200 MS that you have here, you can see that in the preparation mode, if I go into the main screen, you notice that it has the similarity of the die sinking line. So again, your prep and execution is the place you're going to go. And if I go into my preparation zone, I have the modes up at the top, just like I described before, and then the step-by-step procedures that you would walk through in order to generate a program for the wire EDM machine. So again, using the same philosophy between the two HMIs, it reduces the learning curve between using a die sinking machine or using a wire machine, because we use that same look and feel and the same philosophy in the step-by-step procedure to walk through and write a program on the machine. On the Cut 200 MS machine, we have here is a automated door. All right, on this machine here, if I raise the door up so you can see, it's fully automated. Just one push of a button and it can go up, or a push of the button, it unlocks the door and then lowers it, giving you full access to the machine travels of 13.8 by 8.6 by 8.6.